Let's talk about redox reactions. The name redox is coined from the word or words reduction and oxidation. If you look at this redox, we have reduction and what? Oxidation. So in this video, I'm going to explain reduction and oxidation according to their old definition and their modern definitions. So we will see some reactions. I will use some reactions in our explanations. So the first one I'm going to look at is oxidation followed by what? Reduction. That's how I'm going to do that. Oxidation followed by reduction. Now, the old definition, let's start from there. Oxidation, it is the addition of oxygen. Oxidation is the addition of oxygen or the addition of an electronegative element. Then reduction, it is the removal of what? Oxygen or removal of what? An electronegative element. Does it make sense? Now let's use equation of what? Reaction to explain what we mean. Now let's go. We said that oxidation is the addition of oxygen. If you want the reaction between magnesium and oxygen, what do you think will happen? When you react magnesium metal and what? Oxygen, what are we going to form? We'll form magnesium what? Oxide. Then oxygen cannot be written like this. It is diatomic. We form magnesium oxide. Now let's balance the equation. I have two atoms of oxygen, so the only thing, if I add 2 here, I'll add 2 here. The equation is balanced. Now in this reaction, we say that magnesium has been oxidized. We say that magnesium has been oxidized. Reason, there was addition of what? Oxygen to it, and it formed what? Magnesium what? Oxide. Now have you seen oxidation is seen as the addition of what? Oxygen, or addition of an electronegative element. What of reduction? I said that it is the removal of what? Oxygen, or the removal of an electronegative what? Element. The reaction between hydrogen and what? Copper 2 oxide. If we react hydrogen and what? Copper 2 what? Oxide, we are going to form water and what? Normal copper metal. Now watch copper 2 oxide. We say that copper 2 oxide has been reduced to what? Copper metal. Copper 2 oxide has been reduced. Reason, there was removal of oxygen from it. I hope it makes sense. So this copper 2 oxide has been what? Reduced. If we balance the equation, is it balanced? Copper, oxygen, hydrogen are used. It's balanced. So copper 2 oxide has been reduced in this reaction. Now another old definition to what? Oxidation. We say that oxidation, it is the removal of hydrogen. Oxidation is what? The removal of hydrogen. Now let's do it. When we say oxidation is the removal of hydrogen, if you think about the composition of ammonia. Now ammonia, NH3, when it is decomposed, what do you get? You get the element of the Haber process. Nitrogen and what? Hydrogen. Now let's balance. Hydrogen 3. If I add 3 here, I add 2 here. So it's balanced. Everything is balanced. So I have ammonia forming, when it is decomposed, I have formed what? Nitrogen, and formed what? Hydrogen. Now if you look at this reaction, we say that ammonia has been oxidized. Reason, there was hydrogen has been removed from it. I hope it makes sense. So oxidation, it is the removal of what? Hydrogen, or the removal of an electropositive what? Element. I hope it makes sense. Now reduction on its own. What is reduction? Reduction is the addition of what? Hydrogen, or the addition of what? An electropositive what? Element. Now let's do it. Reduction, the reaction, the Haber process, nitrogen plus hydrogen in the Haber process will give us what? Ammonia, right? Now if you balance, you get something in this order. Now we said that nitrogen here has been reduced. Why do we say so? Because hydrogen has been added to it and they formed what? Ammonia. So these are the old definitions of what? Oxidation and what? Reduction. Oxidation, it is the addition of what? Oxygen, the removal of what? Hydrogen. Reduction, it is the removal of oxygen, the addition of what? Hydrogen. Now let's try to move up to the modern definitions, their modern definitions. Now, in their modern definitions, we have, according to electron what transfer, which brings us to oxidation states, oxidation numbers. Now, according to electron transfer, that's the modern definition. If you want to define oxidation and reduction according to that's the modern definition, you have to use according to what electron transfer. Now, according to electron transfer, I would like you to make use of the mnemonic oil rig. Now, O stands for oxidation, R stands for reduction. Now, O means oxidation. This oil means oxidation is loss of electrons. Oxidation is what? Loss of what? Electrons. Oxidation is loss of electrons. That's what the oil means. The rig means reduction is what? Gain of what? Electrons. Reduction is gain of electrons. That's what rig means. So we have to equally use, now in redox reactions, we've tried to explain reduction and oxidation separately. Now for a reaction to be redox, reduction and oxidation must be occurring the same time. It's just like a simultaneous process, simultaneous equation. Two things occurring the same time. So we have oxidation occurring and the same time reduction is what occurring. I hope it makes sense. Now let's try to use a reaction and explain. Now watch the reaction between magnesium and what sulfur will give us magnesium what sulfide. Now what has happened here? Reduction and oxidation is occurring at the same what time. Now I would like you to take note that in reduction, oxidation number decreases. In reduction, oxidation number of the element that is being reduced does what? Decreases. While in oxidation, oxidation number of the element that is being oxidized increases. I hope it makes sense. And I would like you to take again that the one that is being oxidized is the reducing agent, and the one that is being reduced, it is the oxidizing what? Agent. Now let's go. Magnesium reacting with sulfur gave magnesium sulfide, right? It gave magnesium sulfide. Now the question becomes, which one is what? Oxidation, and which one is which process is oxidation and which one is reduction? That which one has been oxidized, which one is what has been what? Reduced. Now watch magnesium. What has happened? The oxidation number of magnesium here is 0 from the rules of oxidation number. Oxidation number of a normal element is what? 0 of a neutral element. Now oxidation number of sulfur here is actually what? 0. Now if we are to calculate the oxidation number of magnesium here, we will see that the oxidation number of magnesium here is what? +2. And that of the oxidation number of sulfur here will be -2. Now, if you watch magnesium, its oxidation number increases from 0 to what? +2. Now, if you watch sulfur, its oxidation number decreased from what? 0 to -2. For that reason, I will say that magnesium has been what? Oxidized. This is the oxidation part. Because remember what I said, in oxidation, the oxidation number tends to increase. While in reduction, oxidation number tends to what? Decrease. So if I'm to represent this thing in reduction half equation and oxidation half equation. Now in oxidation half equation, we say that the one undergoing oxidation is magnesium. Now magnesium is being what? Oxidized. And what is oxidation? Oxidation is loss of electrons. So for magnesium to form magnesium ion, that +2, whose oxidation number is +2, it means that normal magnesium has to lose 2 what? Electrons to form what? Magnesium what? Ion. Now, this -2E minus, let's carry it over here. So we have something of this order. Magnesium, to form magnesium ion, it has to lose 2 what? Electrons. In form of collecting light, and -2 electrons becomes +2 electrons. I hope it makes sense. So this is the oxidation half equation. Now, what of the reduction half equation? Which one is undergoing reduction? It is sulfur. Now, sulfur is undergoing reduction because the oxidation number of sulfur decreased from 0 to -2. Now, it means that sulfur gained what? 2 electrons, right? To form what? Sulfide what? Ion. Sulfur gained 2 electrons to form sulfide ion. Now, if you balance the equation in terms of, if you take the charges, if you check if they are equal. Now, what's the charge here? 2 times minus 1 will give us minus 2. What's the charge here? Is minus 2. So we say that minus 2 is equals minus 2. So this is reduction half equation. It is balanced. Now, if you take the charge here, how many charge do you have here? You have 0 at the reactant side. Now, how many do you have here? You have plus 2, minus 2. Plus 2 minus 2 is 0. So everything is balanced. I hope it makes sense. So I'll be stopping here. One of these days, I'll be balancing Redox what? Redox equations in basic solution and in acidic solution. Have a nice day. Like, comment, share.